So it sounds like you guys want to learn this lesson, so that's what we'll do today. So here's the word. It's called polynomial. Okay, the word, you've probably seen this before. Oops, I got to change the writing up here. I'm sure you've seen this at least in Algebra 1, maybe even pre-algebra. They've talked about polynomials, definitely in Algebra 2. You probably did a ton of stuff in Algebra 2 with polynomial. But what is a polynomial? First of all, that prefix poly, what does that mean? It means not one. It's the opposite of one. It's many. It's many, okay? So let's talk about, and we are going to talk about a monomial, okay? So mono is one, but this is a poly. Poly means many, all right? And what's the nomial kind of thing? Well, the basic, I don't know where they got the word from, but it's basically algebraic terms. I'll just put alg right there. Algebraic terms. So let's write down what that is. What is an algebraic term? Well, I'm glad you asked. So here's examples of what algebraic terms are. Just a number by itself could be considered an algebraic term. All right, a number with a letter. All right, so like 19x. That could be an algebraic term. And then you could have things that are squared. Okay, you could have negatives and then multiple variables. So again, nothing specific about these letters, but every single one of these are algebraic terms. That's a term, okay? That one thing is one term. Even though there's two things here, a 19 and an x, they're multiplied together, so it makes just one big chunk of stuff, all right? Not the most mathematical way to talk about it, but that's one term. Everybody see that? This is one term because they're all being multiplied. This right here is one term, right? A polynomial is basically just a collection of different terms. Everybody got that? Now, they give a real formal definition, but they say it's the sum of one or more terms, okay? That means just a bunch of terms. So if you have a bunch of terms together being added or subtracted, I'll throw that in there, okay? If you have, if all these terms were being added together, that would be considered a polynomial, okay? Let's talk about, let's give us some examples of a polynomial. So let's write this down. So polynomial, and then we're going to get a little more specific. Somebody already mentioned monomial. We're going to talk about that in a minute, but let's do this first. Some examples of polynomials. So basically, it's these kind of things. It's these terms being added or subtracted from each other, all right? So if you know what a term is, and if you add it to something else, then you have two terms, and that's a polynomial, more than one, okay? These would be all one term. And we'll skip ahead. We've already mentioned this. This would be considered a monomial. See, monomial. That's how they do it. They don't say mononomial. They just say monomial. All right, which means it's one term. So that's one term, one term, one term, one term. Even though there's 1, 2, 3 different things here, plus exponents, plus a negative, there's a whole bunch of stuff going on here. It's still considered one term because it's not being added or subtracted. All right, it's not negative 24 plus x to the 4th. All right, it's all just being multiplied, so that's a monomial. Let's do some examples. These are examples of other polynomials. There's nothing special about these. These are just in the book, so I wrote it down. So that's a polynomial. There's two terms. What's the first term in this polynomial? 3x to the second, 3x squared. So that's one term. What's the second term? There's 2x. So it's got two terms. So if a monomial is one term, okay, what's a two-term polynomial called? A binomial, that's right. So we might as well write that down. So that's called a binomial. All right, bi meaning two. All right, so let's do another one. Again, there's more of a specific definition for polynomial. We'll talk about that in just a second. I don't want to get too involved in it, but here's another one. This is kind of crazy looking, but watch this. Tell me, basically, how many terms does this thing have? We're not going to do anything with it. We're not going to do any math with it. We're just identifying stuff. Like I said at the beginning, this is just an introductory lesson to polynomials. All right, so there it is right there, that big thing right there. How many terms does that polynomial have? It's got 3. All right, so take a wild guess. What do you think 3-term polynomial is called? It's a trinomial. No, you don't even, I mean, it seems like it would be, and it probably technically is, but in math, we don't really go beyond 3, all right? As far as naming them, we would just say it's an 8-term polynomial or a 10-term polynomial or a 72nd term polynomial or something like that. All right. A term is just stuff that's being multiplied together, not being added or subtracted. So that's one term. That's being subtracted from this. That's a second term. This is being subtracted from that. That's a third term. So those are your 3 terms. Therefore, it's a trinomial. Okay? Here's something that's not a polynomial, because it looks like everything could be a polynomial, right? But here's something that's not a polynomial. Now, the reason that we're learning this stuff, because we're not doing a whole lot of math right here, but the reason that we're learning this is because later on they're going to say, do something to this trinomial. They'll talk about binomial expansion or things like that. So they're going to use these words quite a bit in the future. So we need to know what those words are and what they mean. All right. So I think it's important that we learn these words. And that's basically what today is. We'll do a little bit of math towards the end of this, but nothing you haven't seen before. All right. So what's not a polynomial? Well, if you had something like this. What makes this not a polynomial? It's not necessarily a plus sign, because this has, right, you could put a plus there, and that's still a polynomial. It's being divided, right. It's the fact that it's being divided, okay? The fact that it's being divided right here. Now look right here. This 3 and this 2 are being divided, aren't they? But the whole entire thing is not being divided by something else, all right? So this 2x is completely being divided by this. This is not a polynomial. It wouldn't be any nomial. Okay? It wouldn't be anything. All right? Here's another one. This is weird. And again, I didn't give you a real specific definition for a polynomial just because I thought maybe it might go over your head a little bit, to tell you the truth. So, but this has to do with it. So watch. If I have x to the 1/2 minus 1. Now that looks like a binomial, doesn't it? It looks like that would be one term and this would be another term. Why do you think this is not a polynomial? What in here looks different than what we've done before? Yeah, the exponent being a half, exactly. Because you can have exponents, right? We had exponents and it was still a polynomial. But having a fractional exponent. You can't have, now listen to this, you cannot have a variable with a fraction for an exponent. Again, in the definition, if you look in the book, it says that the exponent has to be a whole number. Everybody got that? You can't even have a negative exponent. So like this next one. This is an example of not a polynomial. It's a non-example of a polynomial. Look at this. We're not going to get into it, but a negative exponent means that this would actually be x to the 1/3. That's what that thing means right there. I don't know if you knew that, but that's what it means. So, can you have a negative exponent? No, because again, in the book, I didn't write it down for you, but in the book it says the exponents have to be whole numbers. Okay, which means what? What's the first whole number? What's the first whole number? It's 0. That's right. 0 is the first whole number. Okay, so no negative numbers are whole numbers. So you cannot have negative exponents. Everybody got it? I'll just show you what the book says. It says ax to the n. A can be any real number. It can be any real number. So is a fraction a real number? Yes. Any number that you can put on a number line is a real number. So 3/2, that's fine. That can be, all right, it could be negative. Negative is a real number, okay? So A has to be a real number. I'll just put that in there. A real number. And the exponent has to be, what did I say? It's got to be what kind of a number? A whole number. A whole number. So it has to be 0, 1, 2, 3, 4, 5, 6. Can't be a decimal, can't be a negative, all right? So these are not polynomials because of those reasons. Everybody got it? Okay, let's move on. We've already talked about the monomial and all that kind of stuff, so I'm going to skip that since we've already talked about it. So now was the time I was supposed to talk about it. Let's talk about this. Let's talk about the degree. You might have talked about this in Algebra 2. Do you remember this at all? The degree of the polynomial? I don't know, maybe, maybe not. All right, so here we go. Let's everybody listen now. I'll just read off I'll write down what the definition of the book says. So this is a degree. Actually, what we're gonna be a little more specific. We're going to talk specifically about just a monomial right now, okay? So the degree of a monomial. We'll talk about the degree of a polynomial in a second. But just the degree of a monomial. So it's basically this. It says if a is not 0, then the degree, I'll just write it down. The degree, you guys writing this? The degree of, now I'm going to throw something in here that's kind of weird. A x to the n is n. So what in the world does that mean? This right here is a polynomial. Again, I think we wrote that. Yeah, see, we did it right there. Okay. So a has to be what? A real number. N has to be a whole number. But how do I find the degree? If I ask you to find the degree of a polynomial, what are you looking for? Do you care about the a? Do you care about the x? What do you care about? The n. That's the degree of the polynomial. So, for example, what if I had 3x to the 4th? First of all, is that a monomial? Yeah, because 3 is a real number, 4 is a whole number. So, yeah, it's a monomial. But the question's going to be, what is the degree of this polynomial? So the degree is 4. Yeah, this is a monomial. A polynomial just means if I had more of these, if you had these added to something else, okay? So the degree is 4. Where did I get 4? Did I have to do any math? No, I just looked at it and I saw that x, and I said, shh, it'd be nice if I could talk without having to listen to you guys. Okay, just listen. Just listen. You don't have to explain it, just listen. That's all I want you to do. So that right there is the degree of the polynomial. Obviously, they're going to get a little tougher. So what if you had something like this? Again, there's nothing super special about this particular one. It's just the one that they do in the book, so I'm just writing what they do in the book. Z to the 12th. What if they ask you to find the degree? And some of the questions on the homework is going to say, find the degree of this polynomial, right? And what is the degree? Well, what about this one? There's 3. There's 3 variables here. So which one do I pick? Did I write this? Yeah. You add them together. Yeah, I was just waiting. And again, I didn't expect you to really know it, but I thought maybe somebody would guess it. Some people would say it's the biggest one, okay? And we're going to talk about that in a second when we do multiple monomials, right? But if you just have a monomial right here, how do I find the degree of it? I add all the exponents, all right? So what is that? 3 and 2 is 5, and 12 is 17. So the degree of this polynomial is 17. Or sometimes they'll say it's a 17th degree polynomial, all right? But you could just say the degree is 17. That's fine. 2nd degree polynomial, 5th degree, 8th degree polynomial. You'll see that written like that every once in a while, okay? Let's do a couple more. Yeah, because these are a little bit different. So we've got 4 to the 7th, x squared, y cubed. Now, what is the degree to this polynomial? It's a little tricky. I didn't really teach it to you, but let's just look at it and think. Now, the degree, remember, it's a variable, okay? You're looking at the exponent to the variable, okay? Not the exponent to the number out in front. That's a huge hint. So what is the degree of this polynomial? It is 5, right? Because I don't care about this. Why? Why don't I care about that 7? Because it's the exponent to a number, right? Not the exponent to a variable, okay? So these are exponents to variables, right? So what do? I just add them up. 2 and 3 is 5, and the degree is 5. It's as simple as that, okay?
So what if you got like something like that, but one of the exponents are negative?
Well, you can't have, it's not a polynomial, so you can't find the degree of it. Because it says find the degree of the polynomial. So if one of the exponents is negative, it's not a polynomial to begin with, so you can't figure out what the degree is. Does it make sense? All right, let's do one more like this, and then we'll do polynomials. Remember, this is all monomials right now. What if I did this? What if I said, find the degree of that?
Okay. It's 3. Oh, it's 1. It's 0. It's 1, right? It's just 1. It's 3. What are we looking
I heard the right answer, but it was just guessing. It's not 1. It is 0. Why is it 0? I don't even see any exponents there. So how? But there's actually always an exponent.
Exponent is 1, or not exponent is 0. The variable is 1.
It's not the variable. Watch.
When you wrote on the sentence, you put
Look.
A equals /0.
I know. There's your A. There's your X. There's your N. Okay. So why could I do that? What's X to the 0? What's anything to the 0 power? It's 1. It's 1. It's the number. It's the number 1. It's not 1x. It's just the number 1. Okay. So you could rewrite this like this, couldn't you? Because it's 3 times 1. 3 times 1 is 3, right? X to the 0 is 1. So this is true, isn't it? 3x to the 0 is 3. Now I've got it written in the monomial form. So now what's the degree of this? The degree is 0. The degree is 0 because that's the exponent to the variable. Right, got it? Some people might look at it as 3 to the first. Oh, that's that. But remember, the degree is not the exponent to the number, right? It's the exponent to the variable. And if I made it 0, that's a 0 degree. So if you just had a regular number, what's the degree of that? It's 0. What's the degree of that?
0.
It's 0. Everybody got it? What's the degree of that?
0, 1.
It's 1 because, right, because that's x to the what? First. So the degree of that one would be 1. All right?
3x 0, 3x 1.
Because that's x to the first. That's a 0. X to the 0 is equal to 1. That right there.
So now that there's x, then now it's 1?
No.
If there was never x in the beginning, it would be 0. The 3
Yeah, if there was never an x to the beginning, but I changed it though. I made it completely different.
If it's 3x, then it's 1 because those are 2 completely different.
Right, they're 2 different things. 3 and 3x are completely different numbers. Okay? So 237 and 237x are completely different numbers. All right, here's what we really want to get into right now. I tell you what, we got to do a little bit more. Sorry, a little bit more with a degree. Okay, I'm just going to go right to the example. So what we're going to do, the degree of a polynomial that's more than just one monomial, right? If I have a binomial, trinomial, if I got 4, 5, 6, 7 terms, to find the degree, what you're going to do is you're going to find the degree of each monomial, and then you're just going to add them all up. I'm sorry, I lied. That was the other one. You're going to look at all the degrees of each term, and you're going to take the one that's the highest degree. That's the correct way of saying it. Sorry about that first part. So, you like examples probably better than me just explaining stuff. So, now look, this is not a monomial anymore. It's a what? It's a trinomial. Okay, so what we're going to do is we're going to find the degree of each term. What's the degree of this term right here? It's 5. What's the degree of this term?
2.
It's 2. What's the degree of this term?
0.
It's 0. Which one is the highest degree?
3x.
The 5th degree. Okay, the 3x to the 5th. That's got the highest degree. That's a 5th degree. So what's the degree of that polynomial? It's just the highest one, which is 5. So that would be your answer right there. All right, that's got the highest degree. So that's the degree of the entire polynomial, whatever's got the biggest one. Okay?
And if one of the nomials inside of a polynomial has an extra exponent, then you add them together.
If it had, right, if this was like y to the 7th, then this would be 9, and there would be a 9th degree polynomial. Right, then that would be the biggest, right? But it doesn't, so it's not. Okay? Let's do another one. Example. So 7x squared y to the 8th minus 3xy. This kind of does what you were asking. Okay? So you got to find the degree of each monomial, right? Journey, you need to put it away. Okay? You can't. You at least hide it, for goodness sakes. Okay? Put it away. That's not away. So look, right here. What's the degree of this monomial right here? It's 10th, right? Because you add up the exponents. What's the degree of this monomial?
1, 2.
It's 2, because that's x to the first, x to the first, so it's a 2nd degree. Okay, which one's the bigger one? 10. So it's a 10th degree polynomial, or the degree is 10. Okay, I think you got that because we're running out of time. Let's do this. Let's talk about 2 things. Let's talk about putting polynomials in ascending order and descending order. What's the difference between ascending and descending? Yeah, goes up and down. Which one's the ascending? Is it up? Does it go up or does it go down? It goes up. Ascending. First thing, what do you think the first thing comes into my mind when I think of ascending? Of hiking. It should be Jesus. You're probably right. It should be. You ascend up to Jesus. Okay. But unfortunately, first thing that pops up in my head is hiking. So I ascend a mountain, right? That means I go up the mountain. When I descend, I go what? Down the mountain. Okay. So ascending goes from, listen, ascending goes from the smallest degree to the biggest. All right. I'll just put an arrow to we'll just say biggest. Okay? And then descending goes from the what? The biggest to the smallest degree. All right, so here's an example. Are you ready for this? This is pretty important for stuff we're going to do. It's not like the main thing. It's just a little bit that we learn so that we can do other things. This in and of itself is not crazy important, but it does help you do other things. And let's do that. So, what if I gave you this? Write this down. 7x squared minus 5x to the fourth plus 3x plus 2x cubed minus 1. Okay, so they're going to ask you to put it in both of these. Okay, ascending order and descending order. So what we have to do is figure out which one has the highest degree, which one's got the lowest, and put them in order, okay? Actually, we're going to go ascending first, okay? So we're going to go ascending order first. So what's the lowest degree? Everybody, come on. Don't stop. We've still got 2 minutes. But what term is the lowest degree? It's the negative 1, right? So the negative 1 goes first. What's the next highest degree? The 3x. It's because it's x to the first. So it's plus 3x. Then the next one, yep, plus 7x squared. The next one, 2x to the third. And then the last one, negative 5x to the fourth. Okay, and that's good. That answers the question. They're going to ask you the question, put it in ascending order, and you need to do it. But the one that's the most important, that I think is the most important, is descending order. Because when we start doing stuff with these polynomials, we're going to be doing some algebra, some math with this stuff, okay? You normally, almost, I'm not going to say every time, but almost every single time, you're going to put it in what order? Descending order. So let's do that. It's the same thing backwards, exactly right. So it's a lot easier. Once we got it in order, we can just go backwards now. So what is it? Negative 5x to the fourth plus 2x cubed plus 7x squared plus 3x minus 1. This right here, to me, that's the order. It's not just to me. It's the way mathematicians usually do things. When we're going to do stuff with these polynomials. We're going to add them. We're going to subtract them. We're going to multiply them, and we're going to divide them. Remember the video I showed you the other day where they had that long division problem? And I said, we are going to do that with variables and exponents. So we will have to do some long division, but it's probably towards the end of this chapter. All right? But we're going to do stuff with this. Everybody listen. I'm not done. Everybody listen. Shh. We're going to do stuff with this, and for the most part, almost every single time, we're going to take and put it in descending order. So this one right here is the most important part. We still didn't quite get finished, but I did give you a homework. 21 to 51 odds. I'm giving you odds. So it's 21 to 51 odds. You may not be able to do the last section. I don't know what numbers they are, but do as many as you can. Okay, 21 to 51, just the odds. You too.